So example 6.3, you are given transfer function T of S as this. We need to find out how many poles in the left half plane, right half plane, and j omega axis using Routh's table. So I'm going to write S5 and S4, and we need to copy down the coefficients. For S5, we have 3, 6, and 2. And then S4 as a 5, 3, and 1. Starting from S3, we need to use this determinant 3, 5, and negative 3, 5, negative 3, 5. Then we're gonna have this 6 and 3, 2 and 1. And for these guys, gonna be 0 and over 5, over 5, over 5. We good? Yeah, over 5 is from this guy right above. So then that equals to negative 9 minus 30 over 5, negative 3 minus 10 over 5. This is 0. That is 21 over 5. This is 7 over 5 and 0. So we have a 3, 1, 0. And then S2 is going to be 2 above 3 and 5. And I need to have 1 and 3, 0 and 1. Then we have divide by 3. 3 is from here. Then we have a negative 5 minus 9 over 3, negative 0 minus 3 over 3, and that is 4 over 3. This is 1. Can multiply everywhere by 3, so this is 4 and 3. And S1, we have a 4 and 3, and 1 and 3 over 4, 0. That is negative 9 minus 4 over 4, 0. That is negative 5 over 4. And we are not allowed to multiply negative numbers because we do care about the sign. The last one is S0 is negative top 2. So negative 5 and right above 4, and then 0 and 3, right? Over negative 5. That is negative 0 minus plus 15 divided by negative 5. That is negative, negative, cancel out is 3. Anything else? 5 is what? 3, 5, 3, 4, negative 5 over 4, 3. Now we have two sign changes. Therefore, there are 2 poles on the right half plane, and then 3 left half plane, and we have 0 j omega axis. Yeah, so there are 2 sign changes, positive, negative, negative to positive. So that'll give us the right half plane poles. And then we have s to the power of 5. That means there are 5 poles, and 2 plus 3 will give us 5 poles. And j omega axis, we'll talk about in the next problem. It's not going to be always solid numbers, something like this, okay? So there are 2 special cases when we work on this Routh table. The first one is we're going to have 0 in the first column. When I say first column, it's the this guy. So somewhere when we do this determinant calculation, we end up getting 0 only. That's the first case. And also, we're going to have 0 for entire row. So this is the case where you need to think about j omega axis. So whenever we have a 0 in the first column or row of 0, now we need to think about there's a possibly j omega axis pole. Okay, so now before I move on, if you look at this, I'm gonna copy down the 63130, and then these guys are all zeros. And watch here, I want you to take a note on that. When I calculate this for S naught, this for the first time, but this is gonna be the last time. Always S naught is coming from here, because the way of using the numbers, always this is gonna cancel out, and this number is coming from here. And these zeros, always zeros, because we're gonna take two zeros from right side. So these two zeros, regardless of how many orders we are working on, this guy is gonna be zero. So it's kind of the pattern that you wanna know, so that you don't have to calculate S0. We okay? And let's work on the first column zero first. Epsilon method. And if you have an entire row as a zero, then we have to do something about it. Then we'll talk more about it when we get to that point. We have T of S equals S5 plus 2S4 plus 3S squared plus 6S squared plus 5S plus 3 S5 S4 S5 is 1, 3, and 5. So it's the 2, 6, and 3. Then S3, negative 1, 2, negative 1, 2, negative 1, 2, 6, 5, 3. Then we have a negative AED 6 minus 6 over 2, AED 3 minus 10 over 2. That is 0. This is 0. This is 7 over 2. So we don't have to put 0, 0. Okay? So you can just say, well, this is the last column. I need to get two zeros from this side. So I'm going to just put 0. That's fine. Now, this is the clearly only 1 0. If this guy is 0, it's a completely different story that we have to deal with. So next example, it'll show row of 0. If the first number is 0, then we are in trouble, right? Because we're gonna consider only the first column, and we are really care about sign changes, right? So what we can do here is we're gonna let this guy as epsilon, a number, but we're gonna test this as a positive and negative at the end. But right now, it's epsilon as some small number close to 0. You can think of that, or just a random number epsilon, as we just assign that so that we can test the sign changes at the end. Make sense? Then S2 as square term is going to be first two numbers, negative 2 and epsilon, and next two, 6 and 7 over 2, and divide by epsilon. And next number is 2 epsilon, 6, 7, oh, 3. Yep, thank you. 3 and 0, right? And that is negative AD minus 6 epsilon divided by epsilon, and AD 0 minus 3 epsilon over epsilon. And this equals negative 7 plus 6 epsilon over epsilon. This one is 3, and this negative 7 over epsilon plus 6. And then S1 is negative top 2 epsilon, negative 7 over epsilon, 7 over 2 plus 6. Thank you. And S0 is going to be 3. Now for this guy, we have negative of AD minus negative 7 plus 6 epsilon over epsilon times 7 over 2, everything over negative 7 plus 6 epsilon over epsilon. And that is negative 2 epsilon as a common denominator. 6 epsilon squared minus plus 49 minus epsilon. And then negative 7 plus 6 epsilon over epsilon. 6 epsilon squared minus 42 epsilon plus 49 over 2 epsilon times epsilon over negative 7 plus 6 epsilon. Negative 6 epsilon squared minus 42 epsilon plus 49 over 12 epsilon minus 14. Why we are doing this? To check with how many poles on the left, the right half plane, so that we can identify this transfer function is stable or not stable. And we do care about the sign changes in the first column, right? Now, this guy, it's kind of hard to see what happened when we see epsilon is a positive or negative. What if we have epsilon is a positive? I mean, how do you know the whole expression is a positive or negative? It's kind of hard. Now, when you get to this portion for here, we do care about the sign changes as a epsilon is a positive or negative. When we check for that epsilon sign, plus 6 is not much we can do about it. It's a positive 6. So instead of carrying all of this to have a complicated expression, what we want to do, I want to just take only this guy, plus 6, take it away. And then if we do it in here, negative AD3 epsilon minus BC plus 49 over 2 epsilon over negative 7 over epsilon. And that is negative will cancel out. 3 epsilon plus 49 over 2 epsilon times epsilon over 7. And that is, if we multiply 3 epsilon squared over 7 plus 49 epsilon over 14 epsilon will cancel that out. Then, and we have S5, S4, S3, S2, S1, S0. 5 is what? 1, 2 epsilon. 1, 2 epsilon S squared. We have minus 7 over epsilon. And then S1, we have 3 epsilon squared over 7, S0 is a 3. Yeah, we want to look at the sign changes. So what we want to do, we're going to test for epsilon as a positive or negative, see whether we have sign changes here. So when we say epsilon is a positive or negative, this plus 6 is not going to be effect on the sign changes. Now we're going to test for, okay, 49 over 14 is a positive solid number. So we can just ignore that. So this is positive, positive. Epsilon is a positive. This is positive. Negative 7 over net epsilon is a positive. So it's going to be negative. This is positive, positive. If epsilon is the negative, we have a positive, positive, positive. This one is going to be positive. When we have an epsilon, oh no, there's a negative right here. So this one should be negative. Epsilon is a negative, positive, positive, positive. So you should be able to get the same number of sign changes when you test it as an epsilon is a positive or negative. So you don't have to do it both way. You just need to pick one, positive or negative, and test it. So from here, we have 2 sign changes. From 2 sign changes here, therefore, left half plane, right half plane is 2. Now we know right half plane poles are 2. Any questions at this point? Yeah. This plus 6 is nothing to do with the j omega x's. I haven't said anything about the j omega x's yet. Any questions? Right half plane. Okay, we have a 2 because there are 2 sign changes. You need to do this or this, not for both. So in the future, I mean, in your calculation, when you have this epsilon, somehow you need to factor out epsilon square because epsilon square is always positive. So there's a homework problem. You have this complicated problem with the epsilon. Make sure you drop a positive number. If it's a negative, then it's a different story. Any positive number, you can just ignore that. And then when you have this kind of calculation, you want to factor out epsilon square. Now, j omega x's. So these two special cases could have j omega x's poles. Right? Either we have first column number is a 0 or row of 0, then you need to test for j omega x's. How? We need to find the oxy equation. So for when we have epsilon, this first row, first column is only 0, we need to look at the next numbers and find the oxy equation. So we need to get auxiliary equation from epsilon row. How? This is cubic terms, which was 0. The next number is what? We skip every other term. So this guy should be first term, right? S term, right? Because from the beginning, this is s to the power of 5. This is s to the power of 3. This is s to the power of 1. So this all odd coefficients, all even coefficient, all odd coefficient, all even and odd. Make sense? Therefore, when we create this oxy equation, we're going to have 7 over 2 s plus 0 equals to 0. So 7 over 2s equals to 0. We let oxy equation. If we happen to have epsilon in here, then this oxy equation would be, this is fourth power, so 6s squared plus 3 equals to 0. Make sense? If this oxy equation you solve for s, and that s value give us j omega value, like a complex number, then there is j omega x's. For this one, s equals to 0. Therefore, there is no j omega x's and 3 left half plane poles. You ready? I want to divide everywhere by 7. Then S3 is going to be 1, 1, and 6, 6, 8, 8. Divide by 1, equals to 0, equals to 0. We have 0. So now this is the case where we have entire row equals to 0. Okay, now if we have entire row of 0, then we cannot substitute epsilon in here. Therefore, what we need to do, we need to go look at one row up and then find the oxy equation. That is S4 plus 6s squared plus 8 equals to 0. I'm going to call P of S. And then we take the derivative of this guy, d P of S over ds. Then we have 4s cubed plus 12s. And now using these numbers, 4 and 12 instead of 0, and we continue. So the next one, s squared, is going to be negative 1 and 4, 1 and 4, 6 and 12, 8 and 0, divide by 4, and that is negative 12 minus 24 over 4, negative 0 minus 32 over 4. That is positive 12. So it's a 3. It's a positive 32. And then S1, negative 4 and 3, 12 and 8. That is negative. There's a negative to positive, right? And S0 is going to be 8. So now S5, S4, S3, S2, S1, It's 0, 1, 1, 4, 3, 4 over 3, and 8. There's no sign changes in the first column. Therefore, there's no right half plane poles. We're good? Now, just like what we had before, if we solve for this, we have S equals to plus minus J2, S equals to plus minus J square root of 2. You can use your calculator, find the roots for this force power, and we have 4 J omega x's. Therefore, we have only one left half plane. We're going to test for right half plane first, and then check for J omega x's. And then the total number of poles equals the highest power of the poles equation. Any other questions? So in the previous example 6.3, what did you say? How many left half plane was that? Right half plane is 2, left is 3. J omega axis is 0. And can you tell the stability of this transfer function? Anybody? In this example 6.3, we have this. What's the stability? We can say stable or non-stable, marginally stable. Oh, you said you're unstable. Oh, yeah, thanks. Exactly. Why is unstable? Because of this guy. It's unstable. What about this? Exactly. Marginally stable. When we have one or more right half plane, it's going to be what? Unstable, regardless of number of J omega and LHP. So we need to have 0 for either stable or marginally stable. And if you have only left half plane poles, then it is a stable. If you have a J omega axis, then it's going to be marginally stable.